Generally speaking, reverse engineering refers to the process of copying an existing product for the purpose of remanufacture. There's a lot of different ways to do this, from manual measuring techniques to more advanced methods using CMMs and 3D scanning. For many of our customers, the process of reverse engineering will typically involve them taking a real-life object and measuring it with either a tape measure or a set of calipers, and then using that information to create a SolidWorks model. However, some of the customers are now beginning to use 3D scanning to help with this process. So most people watching can relate to the process of measuring a part manually to draw it in SolidWorks. And they will also appreciate that certain models are quite difficult to draw in this way. We're talking about organic geometry and curvy surfaces. They can be really tricky to draw. So for example, if I asked you to draw this desk, I think with a tape measure, most people would be able to draw that fairly easily. However, if I asked you to draw a car body panel or something that has to fit to the human body, or even a sort of a curvy sculpture, something like this, I think most people would find that very difficult. And this is when scan data really becomes useful. It's going to speed up the process and make the final model more accurate. And to be honest, even if the object isn't organic in shape, something like this carburetor body, having to draw lots of features that need to relate to each other accurately can be really difficult, and you end up taking a lot of measurements and it takes quite a while. If you've got scan data as a starting point, then it's going to really speed up the process and make it more accurate. The reason this way of working has become more popular is due to the advancement of the technology. The hardware and software involved are getting more powerful and affordable, and there's loads of different solutions out there to suit all budgets. The scanners themselves range from inexpensive desktop systems all the way to accurate ARM-based solutions that combine CMM and scanning. And some manufacturers have even combined high accuracy with the flexibility offered by handheld solutions. So we're thinking of things like the Creaform scanners. And even if you don't own a scanner or can't afford a scanner, you can still get a company to scan the part for you and take advantage of this way of working. There are two main types of scan file: mesh and point cloud. Point clouds consist of millions of points in space which represent the surfaces of a part. So there are so many points representing the object that they form a dimensionally accurate 3D image. With a mesh file, the points of a point cloud are connected by lines to form triangles, meaning that the file is made up of millions of tiny triangles. And the most common file type is an STL. And those of you that have 3D printers will recognize this file format, as it's what 3D printers use. It's really easy to start using scan data. 3D scanners are becoming much easier to use, or of course you have the option of getting someone else to do the scanning for you. Either way, once you have your scan file, there are several options of how you can actually work with that data. It's quite dependent on the size of the data and what exactly you want to do with it. So for example, if you have a very small STL file, one option is to use SolidWorks directly. You can actually import STL files straight into SolidWorks as either solid, surface or graphics bodies. And if you import as a graphics body, there are some great new tools that have been added to the new mesh modeling toolbar in SolidWorks. Another option is to use SolidWorks with an add-in. If you have SolidWorks Professional or Premium, then you already have an add-in called Scan to 3D, which can help you work with small point cloud or mesh files, and it's really aimed at making simple parts. Alternatively, to work with larger, more complex scan data, you could use one of the many third-party add-ins. At Solid Solutions, the main two that we work with are PowerSurface in RE and Geomagics for SolidWorks. Both bring many benefits to the process. Finally, we have a product called Geomagics DesignX, which is a standalone software that's tightly integrated with SolidWorks. This product is aimed at users who need to work with very large and complex data sets. Yeah, so other things that ScanData is used for. Some of our customers use ScanData for inspection to make sure that the parts they make are accurate. Their manufactured parts are 3D scanned and then overlaid with the original CAD model to check for any deviation. At Solid Solutions, we have software for this called Geomagics ControlX, which will help with the process. Yeah, so the main two workflows that we have for reverse engineering, there's the design intent and the auto surface workflows. And I'll give you an example of each. So something like this carburetor body, this would be a typical design intent workflow. We want to be able to control dimensions and we want to have control over the model. So it's built up feature by feature in a traditional sort of way. Anyone that's made a model in SolidWorks will know how this kind of model comes together. Okay, so what we're really using the ScanData for in this example is as a reference to make sure that we've captured everything in the right place and make sure that it's dimensionally accurate. We can also compare the actual model to the ScanData and do a deviation analysis at any point to check that we've done it accurately. The other type of workflow is the auto surface, which, like the name suggests, is when you want to 3D scan something, we're not going to actually be doing any features. We're using the scan directly to build the geometry. The computer does most of the hard work, to be honest. So I've got an example for you there where a customer wanted to create a component for his car. He had a piece of his bumper missing because he'd had an accident. So it was a one-off body kit. You can't just go and buy this part. So he sent us in the side that he did have, and we 3D scanned it, flipped it round to the opposite direction, and I tidied up the mesh a little bit after scanning it, and then we printed it pretty much as it was. So we're talking maybe an hour, maybe an hour and a half for the whole process. It comes together very quickly, but you haven't got that dimensional control like you would with a design intent model.